Hey guys, I thought we'd talk a little bit more about the problem that we've been discussing. Particularly, I want to address the question of whether or not you have to guess right about the current. The answer is no. Which of the various equations you have to use versus may use, and what all that means in terms of your answers that you get from polysimul. So to begin with, these are the guesses that we came up with last time for the directions of the currents, and I named them the exact same way. And these are 3 out of the 4 equations that we came up with for the loops and junctions, right? We had our 1 junction equation, 2 loops, and then there was another loop equation, which turned out we didn't need. Now, when we put these into polysimul in the previous video, it gave us the currents. And so what I wanted to look at now was, what if I had made a bad guess about the direction of I2? Would that affect my ability to answer the question, right? If I had said I2 went up instead of down. Now, given the guesses that I made, these equations are correct. If, however, I change the direction of any of these currents, my equations are going to be wrong. So if I guess poorly and say that I2 is going up, now the equations that I was using are all incorrect. All right, now in case you're not quite seeing what I am saying, remember the key difference between what we had learned previously about loop equations and about junction, mostly loop equations, had to do with going against the current. And so when I wrote, let's say, this loop equation right here, this sign right here was based on I2 going down. But if it's going up instead, that means that any sign associated with I2 is going to be the exact opposite. And that goes for the junction equation as well, because now I have I2 going into that junction as well, which is actually thoroughly perplexing, because obviously I can't have in real life 3 currents going in and none going out. All right, now the point of this is supposed to be, okay, two things. Number one, how would my equations be different if I had guessed something else for the direction of I2? But also, as you're going to see, I can actually get all of my currents wrong in terms of their directions and still end up with the right answers ultimately. All right, but first I have to correct my equations, which is going to mean, in this case, switching all of the signs for I2. All right, and so now here are all of the correct equations. With my 3 currents going in and none at all going out, terrible guess, but if this is what's drawn, that's the right equation for that. And then notice these signs both switched, and that's because if I follow a loop like this, for example, in this equation, right, I would gain 12 volts from going with the battery polarity, have minus 10 I1 for following the current through the resistor, and then plus 8 I2 for going against the current through the 8 ohm resistor. All right, now let's put these into polysimul and see what happens. Now on the left side, these are the original equations that we got in the previous video. And then over here are the new equations that we got earlier in this video. And the goal here is to compare, okay, how are the inputs different and how are the outputs different? Meaning, what are we doing differently in polysimul? And what is it giving us differently based on this change that we made here in the direction for I2? Now, the changes that we're going to have to make here between these equations versus these ones, again, are only going to have to do with the sign for I2. So this -1 is now going to be a +1. This +8 for I2 here is going to be a -8 over there. Okay, and same story down here. Oop, that should say I2 down there. Fix that real quick. There we go. Okay, so let's put in the new equations right after we take a look at what the solutions were. So the solutions using the original equations are these. Now that we've written those down for comparison, let's plug in the new values into the system of equations and see what happens. You can probably see the change is very subtle because maybe you don't see the difference here. But there it is, that negative sign. That's it. All of the numbers came out right, but I2 has a negative sign in front of it. using these new equations? Well, so you do not need to redo anything. That's actually what that means. We have the right answers. What this negative sign means is we just picked the wrong direction, which is what I kind of said at the beginning of the videos. We made a bad guess. It doesn't go up. The current goes down. All right, which is the guess that we made in the first video, so you shouldn't be too surprised that that was correct because it was more reasonable. All right, now let's talk about what happens when you pick the wrong equations and you, in fact, have an identity. What I've got here so far is, well, I cleared out the first equation, and I'm going to put this one in for equation 2. Okay, so this is number 2, second slot down. This is number 3. So those are already in. I didn't want to erase those. That'd be a lot of extra work. But what I'm going to do to demonstrate my point is use this equation instead of the junction equation. Now, if you remember back to what I said in the previous video, and possibly also the one before that, you're always going to need a junction equation. If you don't use a junction equation, then, well, you'll see what happens. So I have put in my, quote, third equation, right? I used these 3, skipped the junction equation. What happens? Solve, and what the heck is that? Those aren't answers? Exactly. Those aren't answers. What it's told us here is kind of like ratios between them, but it can't actually give us a solution for some reason. Well, the reason it can't give you a solution is because this third equation here is actually an identity. To demonstrate this to you, I will take this equation, and I will take the other loop equation that we used last time, and I will subtract it. So I'm going to put it as -6 plus 6i3 plus 8i2. All right, and then equals 0 for both of those. And if I add those two, or sorry, I'm not whatever. If I add these all up now, we will have 6. Let's see, minus 10i1. Well, these two terms will cancel, and now plus 6i3 equals 0. And you will notice that this equation and that equation are the same, right? We've got 10i1 minus 6i3 equals 6. I'm switching things from one side to the other and changing signs around, so ponder that for as long as you need to. But the point is, these two equations give you this one. This is merely an identity of the other two, meaning it doesn't supply you with any additional information that would allow you to actually answer the system of equations. So you are always going to need a junction equation, okay? Always use junctions. I'm not sure why people forget about them, maybe because it's too easy. They get all into those loops and think that that's going to be how they solve it, but you need to have a junction equation. That's everything I wanted to show you. Thanks for watching.